Hi everyone, and welcome to our video on simple harmonic motion. So simple harmonic motion is often involved with word problems or applications. So it's the motions caused by vibration, rotation, or oscillation, or waves, radio waves, currents, vibrating strings. So it's happens a lot. It really just is when anything is periodic. So when anything is repeating itself. Okay, so like sound waves or radio waves have the shape of a sine curve or cosine curve. Okay, so but in applications, we have just other vocabulary. We call that simple harmonic motion. Okay, and these others do the same thing. They go up and down, up and down, up and down forever. All right, so the one thing that's new, so they changed the letters with these problems, but still it really is the same as what we have been doing. Okay, so little a is now capital A, or capital A is now little a. They use omega, so that's that kind of curly W, omega, and then T for time instead of X. But otherwise, it really is just like a non-shifted, so simple harmonic motion is usually involving a non-shifted sine or cosine graph. Let's just say non-shifted. Then there's one new thing of vocabulary, frequency. The frequency is the reciprocal of the period. So it's written in a different way, but I think if we just state it like that, frequency is the reciprocal of the period. I think that's easier to work with. So we'll see that right now. Okay, so on this, it says each equation describes the simple harmonic motion of an object. In each case, find the period of the motion and its frequency. Okay, so we don't need to graph these. They just say find the period and the frequency. All right, well, I mean, this is the amplitude in case they wanted it. They didn't ask for it, but it took me a second. Done. So I'm going to continue using the same letters that I used in previous videos. So I'm not going to go to omega. You could if you wanted to. Okay, so if you want to do the omega like it is in the box above, that's fine. I'm just going to say b equals 4 though, because I'm going to find the period. The period again is always 2 pi divided by whatever b is. And we can sub it in. There we are, 2 pi divided by 4. 2 and 4 reduce, and we get pi halves. So this is the period. They did want that. Let me box it. Now to get the frequency, all we do is take that answer and flip it. Done. That's it. Frequency is 2 over pi. Okay, so awesome, right? So something added on. So the word problems are actually nicer than a lot of the stuff that you might have had in previous sections of this. So graphing takes a lot longer. All right, so this problem, and also notice cosine was here, sine is here. It doesn't matter. It's to find the same stuff. The curve would look different eventually. All right, so on this one, we see, okay, A would be 10, so the amplitude is 10. Again, they didn't ask for it, but there it is. Here is where I would say is the B value. So 2 pi over 5. And then we can get our period. Always 2 pi divided by whatever that B value is. And now we just need to simplify. I just multiply by the denominator, the small denominator. So the 5's there cancel. And then we would have 10 pi over 2 pi. And then the pi's cancel. 10 divided by 2 is 5. There we go. So there's the period. And then now the frequency. So remember, you can put a 1 down there. Okay, so I ran out of room. That's why I'm marking it up there. But right next to it is where I'm going to put the frequency. The frequency is flipping 5, which would be 1/5. Okay, that's that. Okay, so let's do this one other problem. But frequency you might hear, so like FM, the radio signals, that's frequency modulation, which just means that they're messing with, okay, so frequency modulation. So here's our curve. Maybe they want to make it tighter. So it modulates that, or maybe they want it spread out. Okay, so that's what's happening when you hear frequency modulation. Anyway, so it's still connected to the period, and it's just telling us how that curve is getting stretched or compressed. So let's see one other example though. So it says, suppose a ball attached to a spring is pulled down 10 inches and released, and the resulting simple harmonic motion has a frequency of 3 periods per second. So frequency equals will be 3. Write an equation for the ball's simple harmonic motion. Okay, so instantly, just with our frequency, again, we know what the period will be. Flip it, 1/3. Okay, so we have that information. And then now let's break down the rest of it, or really the start of it. So it says, suppose a ball attached to a spring is pulled down 10 inches and released, and the resulting simple harmonic motion, ... has that. Okay, so if you have a ball on a spring, so we're assuming, I'm going to just kind of draw an XY axis. So we're going to assume here's the ball before it's stretched out. Ball not stretched. And then if we stretch it out to 10 inches up here and then let it go, so we stretch it out this way, once we let it go, we would assume since it's on a spring that it would bounce all the way down to -10. So back and forth, back and forth, back and forth. Okay, so we've got a spring that is stretching. Here's my poor drawing of a string, or spring, I mean. And yeah, getting pulled, and it will fluctuate up and down, up and down, up and down, up and down, like a sine wave. Okay, so that's what we're assuming is happening in this problem. Maybe there's more going on, but I think it's kind of vague to where we can make this assumption. Okay, so and I drew that nasty one, but we'll say I'm going to assume, again, it's at equilibrium, so it hasn't been stretched yet at the very beginning. So this is our t-axis, and this is our y-axis. And it's at 0, 0 at the beginning, and then stretched out to 10, and then back down, and then it goes down to -10, and so forth. So I'm going to say that this is a sine function. Okay, so we've got a sine function that makes that shape. And so I'm still using the y equals a sine of bx to get the rest of this equation down. We already have a, so our a is 10. Okay, so this length right here is the amplitude. And because it's not reflected, we know it's 10, so regular a is 10. And then now back to the period. Right here. Remember again, the period is 2 pi over b. So we can sub 1/3 in and then solve for b. So we can cross multiply and get b is 6 pi. Okay, so we got our b too. So we've got both of these, and then we would sub it in. So y equals 10 sine of 6 pi x. There we go. All right, that's it. Okay, so harmonic motion, not much different than what we had been doing, but probably a little less. Okay, because we did 3 problems in under 10 this time. Nice. Okay, so that's it though. If you do have questions, please let me know. Otherwise, thanks for watching.